Okay, here we are trying to understand what is light. We'll do that in a simple way. We'll not go into much detail, but let's just have small discussion on that. Now, when I use the word light, I basically mean white light also, or we also have another name for it. We call it visible light. The basic definition right now that we may use for light is that it is found to be an electromagnetic wave that produces sensation of sight in us. What it basically means is that we humans can see objects, perceive objects in our environment with our eyes, and all possible because of visible light. Now, the word here electromagnetic wave refers to a group of waves that has oscillations of electric field and magnetic field in them. The examples of all those waves are your gamma rays, X-rays, ultraviolet rays, we have visible light, infrared, microwaves and radio waves. Now all these waves, they differ in the properties, and the main property that differs all of them is the wavelength they have. Now every wave should have a wavelength. Even our visible light has wavelengths. Blue light or violet light having wavelength near to about 4000 angstroms, or we call it 400 nanometers. The highest wavelength in your visible light is for your red color. The red color is found to have a wavelength of around 7000 angstroms or 700 nanometers. Now this wavelength basically means that the electric field that we have, the peaks of the electric field in our electromagnetic waves, the gap in them is what is known as wavelength. For example, as I said earlier, if you have a violet color, this wavelength, the gap between the peaks of your electric field is going to be around 4000 angstroms, whereas for the red color, this gap is going to be slightly longer, or let's say longer, and will be around 7000 angstroms. If we look at this table here, the light that we have, infrared, microwaves and radio waves, they have wavelengths much bigger than our visible light. You can see out of all of them, the radio waves will have the longest wavelength. Gamma rays are found to have a very small wavelength. Now the frequencies in them is just going to follow the reverse order. Gamma rays, they have very high frequency, whereas your radio waves, they have very low frequency. Now this topic is altogether discussed in detail in a separate chapter of electromagnetic waves. For the time being, we are basically want to understand that what is the range of your visible light, the wavelength range. Now waves, they have properties like wavelength, frequency, speed and intensity. We all know speed of light in vacuum is about 3 into 10 to the power 8 meters per second. Exact number is 299,792,458 meters per second, approximate to this value. Now the speed of any electromagnetic wave is decided by your medium also. As you can see, in glass, the speed of this light is about 2 into 10 to the power 8. When we talk about intensity of light, we basically mean brightness. As you can understand from here, that means if we have a very intense light, it means a very bright light. Now this light has been studied by various people from a very long time. The first attempt were made by your Newton, wherein he introduced his corpuscles theory about 17th century. According to him, if we have a source of light, the source of light is going to produce a stream of particles which are elastic in nature, and Newton called them corpuscles. Now these corpuscles, according to him, travel in a straight line. This theory, it could explain phenomena like reflection of light, refraction of light. What this theory could not do was explain some other phenomena associated with light, like your interference, diffraction, polarization. After Newton, the major theory that we have for light was introduced by a person called Huygens. Huygens showed or argued that light is a wave phenomena. Huygens doesn't take the idea of corpuscles in his theory. That means light doesn't consist of particles, but light is a form of wave. Using this principle, Huygens could explain not only reflection and refraction, but he could even explain other phenomena. Later, Huygens' principle was made more advanced by another person called Fresnel. For the time being, we need not go to the details of that. After Huygens, the major idea about light came from a person called Max Planck, where he showed that light consists of particles which he called them photons. This idea comes from what we know as quantum theory of light. For the time being, we need not discuss this part also, but you can see there are many theories related to light. Some are good in explaining some features of light, and some are advanced which can explain advanced phenomena based on light.